Hello dear students, welcome to my channel. Today we are going to discuss the alcohol, phenol and ether and its chemical reactions mainly. And we have already discussed some Kolbe reactions in our previous videos. Go and check it out. Subscribe the channel right now. We are making the 50-minute short videos for you, which is easier to understand the concept. Let's start. So the first reaction which we are going to discuss is today is known as, you can write down with me, Riemann-Tiemann reaction. Very famous name reaction, Riemann-Tiemann reaction. What is this reaction is all about? The phenol is treated with chloroform. Phenol is treated with CCl4. This is chloroform in alkali solution. Alkali solution. And it will form salicylic salicylic and then salicylic acid respectively. Salicylic acid respectively इज्जत के साथ. Okay. So the intermediate reaction where di in the intermediate there will be formation of dichlorocarbon. Intermediate will be dichlorocarbon in between carbon. You must remember the carbon. The formula look like that. CCl2. This lone pair on carbon is known as carbon. Let's start the reaction right now. First make a phenol. This is phenol. It's treated with, as I told you, chloroform CHCl3, or you can directly use CCl4. Both will give the same reaction. Chloroform CHCl3 in the presence of aqueous KOH alkali medium, it will give OH intermediate here carbon CHCl2. Okay, and further react with KOH, it will form again OH CHOH whole twice, and by removing the water molecule, because in this carbon CH there is two OH group present and which is quite unstable. So removing the water molecule itself, it will form salicylic, that is CHO. This will be the formation of salicylic in this reaction. Salicylic. Salicylic. Okay. And if we have used, in case of chloroform, if we have used CCl4, the next reaction would be the reaction with CCl4. So if benzene phenol is treated with CCl4 in the presence of KOH, it will benzene. Here it will come CCl3, and further reacting, it will form OH, COH whole thrice, COH whole thrice in the presence of KOH, and removing the water molecule, it will form salicylic acid, that is COOH, that is salicylic acid. So these are the reactions which you must remember. In the case of CCl4, salicylic acid will be formed. In the case of CHCl3 chloroform, the salicylic will be formed. Okay. So the ring expansion must be there also in some cases. you must remember that also. So suppose you have very important for board exam. Name reaction. We are going to prepare the vanillin, preparation of vanillin, which is like that. So you have OH, OCH3. The common name is glycol, and it will form CaCl3 plus KOH, the reaction, and in the addition of H plus hydrolysis, it will give OH, OCH3 and CHO here, and this is known as vanillin. You must remember for the JE preparation, this reaction, the reaction of glycol form this. The next reaction which we are going to discuss in this is ring expansion. Ring expansion. Suppose you have, okay, this compound with H. When it is treated with CH3Cl plus NaOH, it will give the compound. The ring expansion must be there, right? So the compound will be C, and here the negative won't shift like that, and the double bond will shift. So the Cl will be gone, and it will form the product. It will form the product Cl, that is 3-chloropyridine, 3-chloropyridine, by using the ring expansion method. The next reaction which we are going to discuss is number 2, Claisen reaction. Claisen reaction would be look like that. Remember, OCC double bond C R is treated with 200 degrees Celsius. It will give phenol here, R. So this is known as Claisen rearrangement, where ala- allyl aryl ethers are heated to form ortho allyl phenols, and this rearrangement is known as Claisen rearrangement. Sometimes this reaction need catalyst, right, like SClH2SO4. This type of catalyst needed sometime in this reaction. For example of this reaction is OCH2CH double bond CH2 is heated at 200 degrees Celsius. This is aryl ether. It will form OCH 2CH double bond CH2, that is O allyl phenol. Okay, the next reaction which we are going to discuss is with benzene diazonium chloride. Benzene diazonium chloride, also known as coupling reaction. In this reaction, benzene diazonium chloride, that is N double bond NCl, is treated with phenol at by heating in the presence of NaOH. It will form para-hydroxyazobenzene, which looks like that. N double bond N OH OH plus HCl. So this will be like that. Then we have few more reactions like condensation reaction. And this phenol is treated with formaldehyde in the acidic medium to give this, and further polymerization gives the compound bakelite, which is like that. This is known as bakelite. You must have heard about phenolphthalein, which can be also prepared by this method condensation. For example, you have phthalic anhydride. So this is your phenol with H plus again ecophenol with H plus phthalic anhydride, which is like that. Phthalic anhydride C double bond O O C double bond O O. This is known as phthalic anhydride. So 2 moles of phenol is treated like that in the presence of concentrated H2SO4. It will give phenolphthalein indicator, which is look like that. Draw it like that only. This is known as phenolphthalein. This is an indicator which you used in titration. So these are the reaction, and the oxidation is also done by using K2Cr2O7 or Jones reagent like CrO3 plus H2O, and it will give phenol quinone, which we are going to discuss in next reactions. Oxidation and test of this next video. Thanks for watching. Subscribe now.